Now what we discuss is we discuss a particle thrown vertically upwards from the top of a tower. ఒక పార్టికల్ ని టాప్ ఆఫ్ ఎ టవర్ నుంచి ఫర్ ఎగ్జాంపుల్ I have, let's say, assume that, imagine that this is a tower. This is a tower. Tower of height h. Tower of height h. Okay. Now I am throwing a particle vertically upwards from where? From the top of a tower, so that it reaches maximum height, and afterwards what happens to the particle?
It comes down again.
Yes. So when it is going upwards, what is happening to velocity?
Changing.
Changing means increasing or decreasing when it is going upwards?
Decreasing, sir.
Decreasing. Good. So velocity goes on decreasing when it goes upwards. Now at this point, let me take the velocity of the particle as 0, and let me take the distance covered as y along a straight line. Right? Now at this point, the particle will remain there or it will fall down again?
Fall down due to acceleration due to
Will fall
gravity.
down. Yes. Of course, when it is going upwards also acceleration due to gravity is there. Now when it is coming down, it falls to the foot of tower. It falls to the foot of tower. Because I am considering a straight line motion. Now initially the particle has moved upwards, covered a distance y along a straight line where velocity is 0, and once the velocity of the particle is 0, it starts coming down with increasing velocity because of g, and where it is falling on to the foot of tower, or I can say it is falling onto the ground. It is falling onto the ground. Now my question is, what is the displacement of the particle?
H, sir.
H.
H.
Height of the building.
What is the displacement of the particle? Answer, Nana?
Height
H,
of the
sir.
building.
Height of the building.
ఎందుకు? Good. Why? Why H?
That is what displacement, sir.
Because its initial point is at H, sir, and the final point is at the foot of the building. So H.
Yes.
Okay, fine. But you are very close, but I will say that answer is minus H.
Minus H, sir.
Yeah.
ఎందుకు minus H? Why minus H?
Sir, particle పైకి ఏదైనా
As it is
బిల్డింగ్
Particle
going
is moving.
downwards.
సో పైకి వెళ్ళి మళ్ళీ బిల్డింగ్ టాప్ వరకు
ఫస్ట్ టైం అయితే ఫస్ట్ ఇనిషియల్ గా పైకి వెళ్తుంది. Direction,
Yes, sir.
upward direction I will take as positive, downward direction I will take as
Negative.
negative, right? Upward direction is always positive, downward direction is negative. So when it is coming in the downward direction, then I will take the displacement as minus h. Why? Because even if you calculate mathematically, you will get minus h. So here I can say that answer is minus h. Minus h is the displacement. Now, if you want, let me do the calculation. Okay, initial point is top of the tower. Final point is foot of the tower. Initial point is top of the tower. Final point is foot of the tower. So it is in the downward direction. Height of tower you are measuring from foot of tower to top of tower. This h you have taken as positive. Why? Because height you are measuring from bottom of the tower or foot of the tower to the top of the tower. In the upward direction, what is the sign convention I have taken? I have
Negative,
taken
sir.
the sign convention as positive. But now you are measuring the displacement from top to bottom. From top to bottom in the reverse direction. Right? So when it is in the reverse direction, then I can say that minus h is the displacement. Or let me
Yes,
calculate
sir.
this so that it will be. Let me calculate it. Now tell me what is the distance traveled by the particle in the vertical direction?
Y
Plus H.
Plus y or minus y?
plus Y plus Y.
Plus y.
Why, sir?
So plus y. This is in which direction?
Upward.
In upward direction, right? In
Yes, sir.
upward direction. And what is the distance covered in the downward direction?
minus y, sir.
Minus H.
Minus.
No,
Minus
no.
Y. Yes.
Distance covered in the downward direction, that is from this point to
V.
foot of the tower.
Yes, sir.
Minus Y
Minus Y.
minus H.
Minus h minus y, sir.
Minus Y
Minus
minus
of
H.
y plus h.
Yes, sir.
Y minus downward direction is taken as
Negative.
negative. So this is in downward direction. This is in downward direction.
Direction.
Now, when I sum up these two, what I will get? When I add these two, y minus h. When I expand these two terms, if you expand this brackets, so y minus of minus h. So y minus of minus h. Y and minus y gets cancelled.
Minus H
So
remains.
displacement is equal to minus h. Now, if I ask you what is the distance traveled by the particle? What is the distance traveled by the particle?
Yes.
What
Yes.
should be the answer?
Minus S.
No, distance. Distance under
Plus.
distance traveled by the particle. Distance means total path or actual path covered
Plus
by the particle. So
plus
total
Y
path.
minus Y minus
2y
H.
plus h, sir.
No,
2y plus
2y
h.
plus h. Y in the upward direction, again y in the downward direction till top of tower, and again h in the downward direction. So I need to
Yes, sir.
add these two. So if I ask you
2.
what is the distance
2y plus h,
covered,
sir.
2y plus H, sir.
distance covered by the particle. Distance covered by the particle is nothing but y plus of y plus h. I'm not considering negative sign here because distance is not a vector quantity. I'm
It's
not
a
No,
scalar.
no
considering the
direction.
direction. Yes, there is no involvement in direction. I just sum up the upward distance and downward direction, distance. So y plus of y plus h, which comes out to be 2y plus. This is the distance covered by the part. Fine. Now, in this case,
Yes.
remember, if a problem comes like this, if a numerical is based on the top of a tower, if any particle is thrown vertically upwards from the top of a tower, then what would be the equation of motion for displacement? What would be the equation of motion for displacement?
S is equal to
Now
ut
I
plus
want
half v.
equation of let me use this now. Now I want equation of motion. Equation I want. So let me use this. So using S is equal to ut plus half at square. Now what is that value of displacement? We got displacement, not distance.
Minus h, sir.
Minus H.
Minus,
So can I write in place of S as minus H?
yes sir, of
Yes,
course.
sir.
Minus H is equal to what is U? U is nothing but
Zero.
initial velocity of the particle projected upwards from the top of
Zero.
tower. U is the initial velocity of the particle where you have thrown at that point. I am considering U as initial velocity of the particle. Right? Now U is positive or negative?
Positive, sir.
Positive,
Positive,
sir.
sir.
Because the upward direction will take positive.
Yes,
Right?
sir.
So let me write U into T. T is always positive. Time is always positive.
Yes, sir.
And what about A?
Yes, sir.
Acceleration due to
Minus
gravity,
g, sir.
because of acceleration due
Negative.
to gravity is falling. Yes, not
Minus
plus
G.
G. Minus. See, G is always taken to be negative,
Yes,
irrespective
sir.
of throwing the body. Whether you throw the body vertically downwards or you throw the body vertically upwards, G is always taken to be negative according to the sign convention. Why? In the downward direction, what is
It
the
always
sign
acts
convention?
vertically downwards.
Vertical downwards. So minus G into E square. So this equation simplifies, gets reduces to minus H is equal to ut plus into minus is minus half gt square. Remember this equation, very very important equation. When you have to use this equation of motion, you have to use this equation of motion when a particle or body is thrown vertically upwards from the top of a tower. From the top of a tower, use this formula. Or can I use this one? Or H is equal to what I will get? H is equal to
Minus ut plus half gt square.
minus ut, minus comes here, minus ut, minus of minus,
Less
plus
half GT square.
half gt square. Either you remember first equation or second equation. This is the equation of motion that we write. Important, very important. Okay. So this is one thing. Very, very important. Note it down or take a snapshot. Anyways, it is recorded. I mean, it is recording. Fine. Now,
Sir, when we have to use this,
let
sir?
me ask you one more question. Let me ask you one more question. My question is, with what velocity it strikes the foot of tower? Or with what velocity the particle strikes just before touching the ground? Just before touching the ground. Or I can say with what velocity it strikes the ground. అంటే ఇక్కడ జస్ట్ స్ట్రైక్ కాకముందు
minus v equals to u minus gt, sir.
ఇక్కడ v రాస్తున్నాం v. Let me take v. Now I want this velocity v.
Minus v equals to u minus gt.
But I did not give you time in this. If I do not mention time, then do we have any relation between final velocity, initial velocity, and displacement?
V square minus
V
u
square
square equals
minus
to
u
2as,
square is
sir.
equal to 2as.
Yes. Good. So let me use that equation and let me try to find out the value of v, final velocity. Let me try to find out the final velocity. So how can I find? So using v square minus u square is equal to 2as, I want this final velocity v, but v is in which direction? V is in downward direction.
Downward, sir.
When v is in downward direction, v should be taken as negative or positive?
Negative.
Negative, sir.
So minus v whole square minus, how is initial velocity, direction of initial velocity?
Positive. Upward.
Positive.
Yes, minus v square is equal to 2 into what about g? Sorry, acceleration.
Minus g. Negative
Minus
g.
g into minus h, sir. Minus g into minus h.
Yes.
Minus h.
Minus h is the displacement.
Yes. Sir.
Minus g
2gh, sir.
Yes. So what I will get? V square minus u square is equal to 2gh. From this, v square is equal to u square plus 2gh. Now from this, v is equal to
Root of
square
Root of 2gh plus
u
u,
square
sir.
plus 2gh.
So this is the equation that we write to find out final velocity of the particle when it just strikes the ground, or when it just touches the ground. Final velocity in terms of displacement. Final velocity in terms of displacement. This is how you can calculate. Okay, fine. Important concept, remember. So this is the topic that we are discussing when a particle is thrown vertically upwards from the top of a tower. From the top of a tower. Right? Now if I give you one numerical, try to solve this. Try again. Let me give you one numerical. A particle is thrown. Particle is thrown vertically upwards. A particle is thrown vertically upwards. Vertically upwards. ఒక్క నిమిషం అన్న, జస్ట్ హోల్డ్ అన్న. Sorry. So, where am I?
A particle is thrown vertically upwards.
A particle is thrown vertically upwards uh, vertically upwards from the top of a tower, from the top of a tower, from the top of a tower of okay, from the top of a tower of height h, of height h, right? The initial velocity of the particle, the initial velocity of the particle, the initial velocity of the particle is let's say 5 meter per second, 5 meter per second, right? And it takes and it takes and it takes uh, 10 seconds, 10 seconds to reach the foot of tower, to reach the foot of tower, to reach the foot of tower. Find the height of tower, find the height of tower, find the height of tower, and write down within brackets, take small g is equal to, means acceleration due to gravity, small g is equal to 10 meter per second square, 10 meter per second square. I have given the values on my own.
Sir, please repeat that, sir.
So you, yeah, take small g is equal to 10 meter per second square. Acceleration due to
Sir, will you please
gravity
repeat?
value is, which one? Mottama?
minus 25.
Sir,
Problem మొత్తం
Minus,
చెప్పాలా?
sir, minus 25 meters, sir, height.
ఏమోనన్నా, I'm not sure. I don't know. Let me try. See, what is the initial velocity that I have given?
5 meters per second.
5 meter per second, sir.
5 meter per second. That means u is equal to 5 meter per second is the value of velocity, is the value of velocity initial, is the value of velocity initial, right?
Yes, sir.
Now I am asking height, but in what time it reaches the foot of tower?
Seconds.
10 seconds.
10 seconds. That means t is equal to 10 seconds. T is equal to 10 seconds. I'm asking the value of h. So, but I have given the value of g as
Meter per
10
second.
10
meter
meter
per
per
second
second
square
square.
for our convenience.
450 meters,
Actually,
sir.
value of g should be taken as
450
9.8 meter
meters,
per
sir.
second square. But for easy calculations, I have given 10 meter per second square. Now I am asking the height of tower, h is equal to how much?
450 meters,
So
sir.
formula would be h is equal to
H is equal to minus ut plus half gt square.
half g square. Use this to find out displacement or height of the tower. Minus 5 into
5 into
10
10.
plus half into 10 into t square, 10
100.
square, 100, minus 50 plus 5 into 100, I think. Correct, Anna? Is this correct?
Yes, sir, correct, correct.
One way, 100 into 500. So what I
Yes, sir.
get? Minus 50 plus
Plus
500.
500. minus
Is
450
nothing
meters.
450.
plus 450.
Minus,
Plus వస్తుంది.
yes sir, plus 450. Yes sir, yes sir.
Plus H value is, but when we
Plus
say
4.
height of tower, we always say positive. That negative sign just indicates what? That negative sign just tells about
Direction.
the direction of displacement. I mean, downward direction I'll take as negative. That's it. So, but anyways, if you calculate the height of tower, you'll get positive. Its value is how much? 450 meters. I got 450 meters. Okay. This one, this one.
Sir, under root 5 minus 90 lakh, sir. 9 lakh.
ఏంది 9 lakhs? V square. Where you got V square?
Hidden with that formula sir, b square.
No, I did not give you V. I have given only U. U I have given, G value I have given as 10 meter per second square. Time I have given, you have to use the formula H is equal to minus ut plus half dt square. Depending upon the situation, you have to use the formula. Okay, now let me give you one more numerical. Try this. 2 into 25 plus 20 into 9,000. Okay. Okay. Now let me give you one more scenario. A particle is thrown. A particle is thrown vertically upwards with a velocity of 10 meter per second. With a velocity of 10 meter per second. With a velocity of 10 meter per second. 10 meter per second. From top of tower mention చేసినారా మీకు?
No, sir.
Did I mention top of tower?
No sir.
No, sir.
Okay.
No.
From the top of a tower, of height 500 meters. 500 meters.
Sir, please repeat the question.
A particle is thrown vertically upwards with a velocity of 10 meter per second. 10 meter per second from the top of a tower. Of height 500 meters. From the top of a tower of height 500 meters. Find the velocity with which it strikes the ground. With which it strikes the ground. Can you try?
Okay, sir.
సార్ G value 10 సార్ G value 10 తీసుకోవాలా సార్ లేకపోతే 9.8 తీసుకోవాలా సార్
Take G value as 10 meter per second square.
Ten into root 11 meter per second, sir. Sir.
చెప్పనా
10 into root 11 meter per second, sir.
I want the formula what you have used.
V is equal to root of u square plus 2gh.
So V is equal to square root of u square plus 2gh. Right? So this comes out to be root over what is value u given 10.
10 meter per
So
second.
10 square plus 2 into 10 into height is 500,
500 meters.
which comes out to be 100 plus 10,000, I think.
Yes, sir.
Right? So this is
100 into root 11.
1100 meter per second. I don't know what is that value. So 10,100 meter per second. If you take this 100 then compare to 10,000, I mean I can say 100 is negligible. If I neglect this 100, somehow we'll get the value. See, when you compare this 100 with
100
respect
meter
to
per
10,000,
100 meter
this
per
is
second sir
then you neglect this 100 and accordingly you do. But anyways, I mean, I have given my own values. That's the reason you are getting this odd type of answers. 10,000, 10,000, 10,000 ki root enta. What is the value of 10,000 under root?
100.
100, sir.
100. Yes. So nearly 100 meters per second you get. Close value should be nearly 100. I mean, this is close value. This will be approximately 100 meter per second. That means it strikes the ground. It strikes the ground with a speed of 100 meter per second. Okay, ma'am? Fine. Now, okay, let me ask you one question. Do you have any idea about velocity of sound?
330 to 340 meter per second sir
In which
Okay.
medium, sir?
330 meters per second is the value
in
of
vacuum sir.
velocity of sound at 0 degrees Celsius.
In
At
vacuum,
0
no.
degrees Celsius, because velocity of sound, see, velocity of sound depends upon temperature. As temperature increases, velocity of sound also increases. Anyways, we'll do that in second year. But for time being, remember, What is the value of velocity of sound? Velocity of sound at 0 degrees Celsius is
This is
how
330
much?
meters per second.
330 meter per second.
Velocity of sound is equal to 330 meter per second at 0 degrees Celsius. But if I go on increasing the temperature, velocity of temperature also increases, right? And at room temperature, what is your room temperature? Room temperature is nothing but room temperature is 27 degrees Celsius.
1 degrees.
27 degrees Celsius. At room temperature, its value, velocity of sound will be approximately 340 meter per second. Anyways, I'm giving you the value of velocity of sound at 0 degrees Celsius is how much? 330 meters. Or, this is approximately, not exactly. Approximately 330 meters per second. Now, one question is there, one beautiful question, which was asked frequently in competitive exams. In competitive exams, in competitive exams, question is, let me think now. Let me think. Actually, I don't have numericals in my mind, but anyways, I'll tell you 3.43 or something. Okay, sir. Yeah. So let me give you one question. Write down. Assume that this is a well. This is a well contains water, and the surface of water is at a height of uh, is at a height of, let me, okay, let me give you, I'm not giving any numericals. Water is at a depth of h. Water is at a depth of h from the top of the well. Water level at the depth of water level is at a depth h from the top of the well. From the top of the well. Okay. Now assume that a person has dropped a stone. A person has dropped a stone from the top of the well, right? And he hears the splash of sound. He hears the splash of sound in t seconds. T is what? What is this T?
Time.
T is the time taken
Measure to
by a person. Time taken by a person to hear the splash of sound. To hear the splash of sound. Time taken by a person to hear the splash of sound. Okay. This is total time. This is called as total time. Why total time? Because see, when a stone is dropped from a height h, I will take this downward time as t1. Downward time as t1. What is t1? I'll take t1 is what? Time taken by the stone to reach the water surface. Water surface. వాటర్ సర్ఫేస్ కి వచ్చేంత వరకు టైం ఏమనుకున్నాం t1 అనుకుంటున్నాం. t1 is nothing but time taken by the stone to reach the water surface. Now what is the initial velocity of the stone? Because it is dropped.
0, sir.
It is
0.
0, sir.
So this should be 0. This should be 0. Now when can you expect this person hears this flash of sound?
When it reach to the water, sir.
Again, the sound has to travel from water surface to the ear of the person. That time also I need to consider. And what is this t? I said t. I said time taken by a person to hear
Time
this
taken.
flash of sound. I mean total time. I can
Yes.
say that total time. Total time. Right now, during the upward direction, if I take the upward direction time as t2, if I take the upward direction time as t2, then can I write this t as t1 plus t2? See,
Yes,
when
sir.
we
Yes,
take
sir.
t2 is nothing but what? Time taken during the upward journey, or let's say like upward direction. Time taken during the upward direction to hear the sound. Now here I can write like t is equal to, I can write t as, now I can write t as, I mean total time, t is equal to t1 plus t2. T is equal to t1 plus t2. Now what is the value of t1? How to find out t1? How to find out t1? How to find out t1? See, t1 is what? During the downward journey. I'll use this equation.
T1 is equal to T minus
S is equal to ut plus half at square. I'll use this equation. Using S is equal to ut plus half at square, and t1 is the time taken during the downward journey. And what is the distance covered by the stone
H.
during the downward journey? H. So can I write S as minus H? Why minus H?
Sir, board completeless.
It is down
Ipudana?
downward.
It is in the
Vertically
downward
downward.
direction. I'll take minus. Yes, minus H is equal to, what is your view?
0.
0. 0 into which time?
T1.
T1 plus half into what is your K?
Gravity.
Minus G. Yes, T1. Right? So if I solve, what I will get is minus H is equal to minus half G T1 square, minus gets cancelled, right? From this, T1 square will be, T1 square is equal to
Root of
2h by
2h
t.
by b, sir.
From this I will get T1 as square root of 2h by t. I will get the value of time T1 as root over th upon g. So T1 is equal to square root of 2h by t. Now, how can you find out T2?
Sir, shall we wind
This
up
is
today,
very
sir?
important. How can you
Sir,
find
we have
T2?
botany
Sir,
class.
yes, sir. In
Time
fine.
అయిపోయిందా?
Yes, sir.
Botany sir ఇక్కడ ఉన్నారు కదా? Botany sir is here only.
T minus
I will wind up the
T1.
class when Botany sir comes. Don't worry. Botany sir is here only with
Okay,
me.
sir. Okay, sir.
Sir, T minus T2. T1, T2 is equal to T minus T1.
But again, what is the distance covered during the upward journey?
Plus h.
Plus h, right? Because during the upward journey, again the same distance it has to cover. So during the upward journey, and with what speed it goes? With what speed?
330
Because
meter per
person
second.
has to hear this sound, is it not? So
330 meter per
the
second.
moment this 330, let me take it as Vs. I'm generalizing the concept. So I don't know the value of velocity of sound right away, but here I'm generalizing the concept. So with what velocity the sound will travel in the upward direction? Vs. Let me take that as Vs. Vs is what? Velocity of sound. In what time it is traveling with the velocity of Vs? In what time it will travel?
T2 seconds.
T2 seconds, because during the upward journey I'm talking about. During the upward journey, what is the time taken? T2 seconds.
sir.
So during the upward journey, can I use this? Because and as you know very well, velocity of sound is constant or not? Velocity
Yes,
of
sir.
sound is constant. When velocity is constant, what is your acceleration?
It will be
Zero, sir.
constant, sir. Zero.
Zero. Now once
Zero,
again
yes.
I'll use the same equation. S is equal to ut plus half at square. What is the value of S?
Plus h.
H.
Plus h is equal to, what is the value of u?
Minus UT. Minus UT.
0.
Don't take this u, because now I'm considering the upward journey. This u should be velocity of sound.
U.
330 meter per
Listen,
second.
velocity of sound into what time?
T2
T2 plus
half
acceleration is
minus g.
Minus G.
no.
Sorry, sir. 0, 0, sir. 0,
What
sir.
is this
0, 0, sir.
zero? Why zero? Since velocity of sound is constant. Velocity of sound is constant. Whenever velocity is constant, its acceleration is zero. So from this, what is the value of T2?
Sir, we can't see, sir. Can you put some down?
H by Vs.
H by
H by
Vs.
velocity of sound, sir.
H by velocity of sound. Good. H by Vs. Now, what is the value of T1 you got? What is the
Under
value of
root
T1 you got?
Root 2 h by
root
g.
What 2h by g? What is the value of T2 you got? H by Vs. Now I want total time taken by the person to hear the splash of sound. Therefore,
root
I
2h
can
by
say
g
that
plus h by vs.
T is equal to root over 2h by g plus h by vs. Very, very important formula. Remember this form. Remember this form. So whenever a stone dropped into a well of depth h, and if he asks total time taken by the person to hear the splash of sound, formula would be T is equal to square root of 2h by g plus h by vs. H by vs. Important concept. Okay, let me wind up the class for today. Okay, Rana? Right. Thank you all. Let's do next class. Thank you.
Thank you, sir.
Thank you.